Let's start. Last session we talked about for thermodynamics part 1, correct or not? I asked 2 questions from 5 minutes or 10 minutes. I asked for the last exam we solved together. How many exams we solved together? 4 exams, 3 exams. Second questions, we finish 1 session for thermodynamic or 2 sessions for thermodynamic? No one reply me.
1 session for thermodynamics, sir.
Okay, so this one for the second session is okay. How many
Yes.
exams we solved together? 4?
Exam 4 was attempted last.
Last one is exam 4. Okay.
Yes.
So I sent by the way exam 5. Okay. We
Yes, sir.
proceed in the right way. I think some engineers still not join. Ask for link. By the way. Let's continue for the part 2 for thermodynamic. Actually, for the part of equation of gas equation, BV equal nRT. We study some notes for this last session, and we continue today. P here is pressure, V is volume, number of moles is N, R is gas constant. We can set this R bar or RU, R universal. T is temperature. Temperature is must be Kelvin. P is must be absolute. What else? This is R. R here, it is one value valid for all gases. This universal gas constant. This universal gas constant. So R for this one, for example, it is 8.314 joule Kelvin mole. And what is the other values here? It is equivalent for this value, but different units, only different units. That's it. It's the same, exactly the same, but only what different units. So all this refer to what are universal, and this R, it is one value for all gases. This is valid for all gases. Okay. This is one of the main difference between this equation and the other equation BV equal MRT. What is the other equation BV equal MRT? This is coming from this relation. What is this relation? This is a relation between the mass and number of moles. This said the molar weight or nuclear weight, this one M, molar weight, which is a value for the periodic table for the any molecules, like for example H, we'll found this is 1. For C, it is actually 12. For CO2, so this is 12, and this is 23, which is 23, which is equivalent to 44. This is actually the value of M. Equal what? M small divided by N, number of moles and the mass. So to can convert this one to other equation, let's see here, P V equal, this is N, we substituted instead of this by this equation. So if we need to substitute it, N is equal M by M. Let's write this M by M, R universal temperature. So let's take this 2 R universal with M together and obtain another value for this is said R. What is this R? This gas constant with a specific gas constant related for each gas. It depends for each gas. Coming from where? Just to divide for the R universal divided by the M, not molar weight or molecular weight. So molar weight or molecular weight coming from where? R equal R universal divided by M. Clear? So we write this equation at the final, BV equal MRT. What's different? This is R for the above equation. This is universal gas constant, which is one value for all gases. But R here is no. This is R for each gas. It means R for air, not the same R for carbon, not the same R for oxygen, not the same R for CO2, not the same R for CH4, and so on. Each R is different. But here R for air is the same R for CO2, is the same R for CH4, whatever the type of the gas, not depend on the type of the gas, is one value valid for all. For when using the number of moles, this PV equal nRT. But when using mass here, we use this R, which is related for each gas. This clear for difference between these two? Okay, containing for this, I think we use this relation for last exam, we solved it together. One of the problem we use it. BV equal MRT. When you take this volume and put it in other side, what we found? This is mass divided by volume. What is refer mass by volume? Mass by volume, it means density. This mass by volume, it means density, rho. So we can write it, this equation as P equal rho RT. For other shape for this, but this is a function for M. Don't care about for this. Just take this one, which is an important one, and use it for some relations exam. B equal rho RT. Coming from where? Just will divide mass by volume. We divide mass by volume. That's it. Which is mean put the volume in other side. Clear? The expression for the sensitivity of pressure thermometer, change in pressure per unit change in temperature for an ideal is?
A, sir, A. A.
Here he gives you the sensitivity of pressure thermometer as a definition here, which is meaning
N by
the
R.
definition pressure per unit temperature. So this is finally what I want. BV equal N R bar T. So I needed B over T. So B over T is equal. T is going to other side here. So V is going in other side there. So N R bar V. This is which one?
D.
Here.
Oh.
Let's check some examples for this point to apply for BV equal MRT. I guess at standard temperature and pressure, which is meaning STB. So we know now one of the abbreviation STB. STB is standard temperature pressure. Has a temperature of 273 Kelvin and the pressure of 1 atmosphere. What is the volume of 1 mole of the gas at STB? So what is the temperature? 273. So this is the temperature 273. Pressure is 1 atmosphere. This is 1 atmosphere. And the number of moles is 1 mole. This is number of moles. R, I will select the R. This is which R? This R universal. Which R I will use? I use it one, select one, match it with the units here. Like here, the atmospheric. I use it this atmospheric with liter. So we will get the volume by liter. Okay. It means this value is equivalent to what? Equivalent to 8314. Exactly the same, but different units. Okay. So what's your equation we write? BV equal nRT. What is the unknown? V, which is equal nRT, R universal, by B. And we have temperature, we have pressure, we have all units matched together, no problem. And we will get it the volume by liter according to the unit used for R here. So we substitute directly by all numbers and we get the volume by liter direct. That's it. Okay. Any question? Other question, but maybe you have one little idea here, extra idea here. What is this? He give you 2.12 grams. So this is a mass of CH4. So the type of the gas here, CH4, right? CH4 to be aware. Occupies a volume of 200 milliliters. So this is the volume. So it will be 0.2 liter. And the temperature is 35. So plus 273 to be changed to Kelvin. Okay. So required here is a pressure for any millimeter mercury. So the required is pressure millimeter mercury. Okay. How to get it pressure? This is BV equal nRT. So by substitution for this equation, how to get its answer? B, this is required. So B is equal nRT over V. We have V, yes. We have T, yes. Remaining missing N and R. Okay, let's see. For example, if you needed to use it, R here, R is as a general universal here, RU. So I use it R universal, which is equivalent to something like this. B equal nRUT by V. RU, I use it also the unit valid, which is liter atmospheric mole Kelvin. Okay, this is the RU. Number of moles, how to get a number of moles? We don't have number of moles, but we have mass. So let's see the equation. M is equal what? M is equal M by N. So, but I need what? N. So N equal M small by M capital. So M small we have 0.12 gram. So M small 0.12. But what is M capital? M capital is molar weight for this one. So what is this? Carbon
16.
is 12 plus
16.
hydrogen is 1. 1 multiplied 4 is 4. So is equal 16. So divide 16. Get it out. This one way. You have another way? Yes, we have another. What is the other way? Actually, the equation he used for this problem, this one. But I have another way to solve. What is this another way? I use it direct BV equal MRT. Great. So B is equal MRT over V. Great. But be careful. R here is not R general. R for a specific gas. Which gas here? CH4. But I don't have R, not given. So how to get it? So to get this one, it is R U by M. Correct or not? Sorry, this R. R is equal what? RU by M. Correct?
Okay.
So it is the same answer, but with a different way.
Yes, sir.
You have a question? So M, and this is R. I will write it RU by M. And this is T, and this is V. It's the same exactly as we did it by any two way. It's the same. We get it at the end. Why? Because here M by M, what's the meaning for this? Actually is N. You understand me?
Yeah.
So solve it by this way or by this way, you get it the same answer at the end. Clear? Because as finally, this equation here is the same equation here. Because here at the end, RU, I get it here, it's used by RU. N is M over M, so it's the same at the end. Clear? Anyone use it by this, you get it the same answer at the end. I have missing something. Pressure here, we get it at the end by which unit? By atmospheric. So once you get it atmospheric, not this is the final answer because you need millimeter mercury. So we need to convert from atmospheric to millimeter mercury. What is the conversion? 760 millimeter mercury is equal to 1 atmospheric. So I write it like this. This is atmospheric. So write atmospheric below and the millimeter mercury above. 1 atmospheric is equal 760 millimeter mercury. Cross multiplication, which one is up and down like this, multiply this, divided 1, get it the correct answer, millimeter mercury. Okay? Any question?
Clear, sir.
Here, the volume of a bubble starting at the bottom of the lake at 4.55 Celsius increases by a factor of 10 as it raises to the surface where the temperature is 18.45 Celsius and the air pressure is 0.965 atmosphere. Determine the pressure at the bottom. We will find here different things is going to be changed together, which is change, pressure is change, volume is change, temperature is change. So the three is changed. And in this case, we consider number of moles is the only constant. And for this case, we can keep it like BV over T is equal BV over T. Case 1, 1, 1, case 2, 2, 2. Okay. So what is the given here? According to the given, we can get the answer direct. What is the given? Given the volume for V1 is V, V2 is 10V, and T1 is 4.55 plus 273, and T2 is equal 18.45 plus 273, and B1 is equal 0.965. No, this is B2. B1 is the required. That's about it. That's it. Okay. What is the unit here for this? Atmosphere. It's Kelvin. Kelvin. So here this is will get by atmosphere also. Any question? Any question?
No, sir.
Is this what we talk about actually? One is characteristic gas constant, which is a specific R. So here we will found the R value for air. This is for air. But here this is general gas constant, universal one. So this is R is one is general, valid for all gases. Also at 300 Kelvin, this important value should be aware. CB, this all for air. This all for air. Please save it and keep it in memory. CB is 1 kilojoule per kilogram Kelvin. CV is 0.71 H kilojoule per kilogram Kelvin. K is 1.4. K have another symbol is gamma. Okay. What is CB? This is specific heat at constant pressure. So what is CV? Is a specific heat at constant volume. Actually, R here, R specific characteristic gas constant, R is equal CB minus CV. And the gamma is equal CB over CV. Okay, this is the equation coming or to get R and gamma. Specific heat of air at constant pressure is equal to
1.
Is this actually to said specific heat at constant pressure, specific heat at constant volume? This means it is the amount of heat required to increase temperature 1 degree C when heat is given at constant volume. And for constant pressure is the same meaning, but just at constant pressure. Let's see some questions like specific heat at constant pressure is greater than the specific heat at constant volume. CB is equal to 1, but CV is equal to 0.718. Why? Actually, because a specific heat at constant pressure, we also have, or we consider also in the calculations, the expanding happen. We have expanding. Hello, you heard me?
Yes, sir. Yeah.
Okay.
Yes, sir.
We have expansion also we happen, so it's written for the work obtained or something like this. So this including for the CB. So this is the reason for CB value is greater than the CV value. So the heat capacity for the B is greater than CV because when heat is added at constant pressure, the substance expanded and obtain a work. Same what you said. Other questions. We have why we have two values for specific heat for gas, and we only one value for solid and the liquid. Actually, because in case of gases, we have a relation between pressure and volume is inversely normally is inversely proportional, correct? So we use it two parameters here: one constant pressure and one constant volume. This is in case